We are told the pedigree chart represents the inheritance of color blindness through 3 generations. And we see this here. The standard convention is a square is male, circle is female. If it's colored in, that means that they exhibit the trait. In this case, it's color blindness. So Bill exhibits color blindness. His phenotype is colorblind, while Bonnie does not exhibit color blindness. Color blindness is an X-linked recessive trait. If Barbara is expecting another child, so this is Barbara right here, what is the probability that it will be colorblind? So pause this video and see if you can figure that out on your own. All right, now let's work through this together. So they're asking us about their next child here. What is the probability that it is going to be colorblind? And to help us with that, we can try to figure out the genotypes of Tom and Barbara. So Tom is pretty straightforward. He is male. We know that because there's a square there. So X has an X chromosome and he has a Y chromosome. And color blindness is an X-linked recessive trait. And so let me just make clear what's going on. So I'll do lowercase c for colorblind. Colorblind. And I could do a capital C for the dominant trait, which is not colorblind. But since they look so similar, I'll just use a plus for not colorblind. Not colorblind. And so Tom, his phenotype, he is colorblind. And he only has one X chromosome where what the colorblind trait is linked to. And so that must have the recessive allele right over there. So this is Tom's genotype. But what about Barbara? Well, we know Barbara is going to have 2 X chromosomes because Barbara is female. And we know that both of them can't be lowercase c because then Barbara would exhibit colorblindness. But how can we figure out her actual genotype? Well, we could look at her parents. So Bill over here is going to have the same genotype as Tom, at least with respect to colorblindness. He is male, so he has an X chromosome and a Y chromosome. And because he exhibits colorblindness, that X chromosome must have the recessive colorblind allele associated with it. Now, Bonnie, we do not know. She will be XX, will have 2 X chromosomes. Like Barbara, we know that both of these can't have the recessive allele because then Bonnie would be filled in. She would exhibit color blindness. But we don't know whether she is a carrier or whether she isn't. But let's just think about where Barbara got her chromosomes from. One of her X chromosomes comes from her father. And the other one comes from her mother. So if she got this X chromosome from her father only has one X chromosome to give, the one that has the colorblind allele. So if this is from her father, it must have the colorblind allele here. And we know that the one from her mother does not have the colorblind allele because if it was like this, then Barbara would be colorblind, and she isn't. So we know that this must be a plus here. It is the dominant non-colorblind allele. And so now we know both of their genotypes. And we can use those to then figure out the possible outcomes for their offspring. So for example, Tom can contribute a X chromosome that has a colorblind allele or a Y chromosome. And Barbara, right over here, can contribute an X chromosome that has a colorblind allele or an X chromosome that has the non-colorblind allele. Barbara is a carrier. And so let me just draw a little Punnett square here. And so we have 4 possible outcomes for their children, and they're all equally likely. So you can get the X chromosome from Barbara that has the colorblind allele and the X chromosome from Tom that has the colorblind allele. You could have the X chromosome from Barbara with the colorblind allele and the Y chromosome from Tom. You could have the non-colorblind X chromosome allele, or the X chromosome that does not have the colorblind allele on it, and get the colorblind X chromosome from Tom. Or you could have the non-colorblind X chromosome and the Y chromosome from the father. So there's 4 equal scenarios. And so in how many of these scenarios is the offspring colorblind? Well, here we have a colorblind female. She has 2 of the recessive alleles, so that female will be colorblind. This is a female carrier, but they will not show the phenotype of being colorblind. This over here is a colorblind male, has only one X chromosome, and it has the colorblind allele on it. And this is a non-colorblind male. So out of 4 equal outcomes, 2 of them have the offspring being colorblind. So 2 out of 4, that would be a 50% probability that the offspring will be colorblind.